Today we're going to look at a brand new paper about ambient trichloroethylene and its connection to Parkinson's disease. Along the way, we're going to learn about chemical plumes and how industrial activities from over a century ago might be affecting our health right now. According to Wikipedia, trichloroethylene is an organochloride with a formula C2HCl3, commonly used as an industrial degreaser. It is a clear, colorless, non-flammable, volatile liquid with a sweet chloroform-like pleasant, mild smell and burning sweet taste. That's funny. I've worked with chloroform quite a bit as a chemist, but I've never tasted it. So I am curious if chloroform, like trichloroethylene, has a burning sweet taste. It's also been used as an extraction processor. So the textile industry has used it for the extraction of different compounds present in cotton and wool and other types of fabric. It was used for manufacturing refrigerants. And it is occasionally added to a range of products including paint thinners, paint removers, cleaning wipes, carpet cleaners, adhesives, lubricants, pesticides, spot removers, and even typewriter correction fluids. It has been banned in pharmaceutical use and some other uses, so apparently it used to be used not too long ago as a dry cleaning agent, and people were handling it quite a bit, but it has been banned. Actually, my mom told me that she used to use this compound when she worked for an electronics manufacturer. They would do rubberized coatings on certain electronic components, and when they were, if they applied them wrong, they would have to remove the rubberized aspect and then recoat it. But they used these baths of trichloroethylene, and they would get in there with their bare hands and kind of scrub it away, and then. Apparently, they used to illegally dispose of the trichloroethylene by dumping it down the toilet. Not my mom, but this is something that she found out a little bit later. So it's really interesting to me, and it does match my experience a little bit with certain chemicals, is familiarity breeds contempt. And so you just develop kind of a blasé attitude about certain chemicals if you don't know the hazards. But it's really interesting to think about kind of changing attitudes about safety when it comes to our exposure to certain chemicals. According to Google, trichloroethylene is still used as a metal degreasing agent, and it's used in electronics cleaning as a cleaning agent still. So apparently that's still an active use. According to the CDC, relatively short-term exposure of animals to trichloroethylene resulted in harmful effects on the nervous system, liver, respiratory system, kidneys, blood, immune system, heart, and body weight. There is strong evidence that trichloroethylene can cause kidney cancer in people, and some evidence that it causes liver cancer and malignant lymphoma, a blood cancer. It's interesting, given the topic of the paper we're looking at today, that the CDC article makes no mention of Parkinson's disease. However, another source I found said that the colorless chemical was first linked to Parkinsonism in 1969. Since then, 4 case studies involving 8 individuals have linked occupational exposure to TCA to Parkinson's disease. In addition, a small epidemiological study found that occupational or hobby exposure to the solvent was associated with a 500% increased risk of developing PD. In multiple animal studies, the chemical reproduces the pathological features of PD. Back to the CDC article. Most trichloroethylene in surface waters or on soil surfaces evaporates into the atmosphere, although its high mobility in soil may result in it moving into the groundwater below the soil surface. In these subsurface environments, trichloroethylene is only slowly degraded and may be relatively persistent. Then, trichloroethylene and other volatile organic chemicals may diffuse from contaminated groundwater and soil and migrate into air spaces beneath buildings to enter the indoor air, a process termed vapor intrusion. So how do you get exposed to trichloroethylene? You may be exposed to it from the contaminated air, water, food, or soil, or direct skin contact. You are most likely to be exposed to trichloroethylene by drinking trichloroethylene contaminated water, but you may also be exposed by breathing in trichloroethylene released to the air from the trichloroethylene contaminated water. Of course, if you work in an industry that uses it, that's going to drastically increase the chances of exposure. And that gets us into the idea of this paper, of the paper we're going to talk about today, which is about essentially old trichloroethylene chemical plumes and what they may be doing to people's risk of Parkinson's disease today. So Google says that a chemical plume is a cloud of diluted chemical contaminants that forms when pollutants are released into the environment, such as from a fire, spill, or leak, and are then dispersed by air or water currents. These plumes can consist of gases, vapors, particles, or even dissolved substances in groundwater and pose health and safety risks. So that's basically what we're talking about, is if you have an area where there's been long-term sustained use of certain chemical pollutants, then over time they collect in the groundwater and then they stay there. And you could say this area of highly concentrated pollution is a chemical plume, and it's there in the groundwater, and it could be showing up in drinking water, or like we were talking about with vapor intrusion, it could be kind of slowly diffusing up into the soil and then getting into people's basements and things like that. So the main question of this paper is whether these chemical plumes and their geographical dispersity can be connected to Parkinson's disease rates. Oh, Kat, can you please? Thank you. Oh my goodness. My cat is walking all over. So basically the method of what they did here is that they are correlating the incidence of Parkinson's disease among Medicare beneficiaries. So they're looking at an older age group. They're correlating that to the basically maps of TCE exposure areas. So certain geographical regions are associated with trichloroethylene plumes, and they're basically trying to break these into rank them into different levels of exposure in those areas, and then see if there is a correlation. This is the first graph that I want to look at from this paper. It's ambient TCE levels from 2002. This is a map of census tract level annual average ambient TCE concentrations in the US based on US EPA data. So you can see where it mostly shows up. So trichloroethylene, not surprisingly, maps to kind of the, past centuries major industrial areas. As such, there's a huge amount in the Rust Belt and kind of the old, Midwest manufacturing hubs. And then there is also another major hotspot, basically following the path of the traditional chemical industry locations, where traditionally there have been a tremendous amount of chemical companies, and unfortunately the groundwater also reflects that. The main finding of the paper is to essentially take that map and correlate it with the relative risk of Parkinson's disease based on more census data. So you see on the x-axis that they have the average annual trichloroethylene ambient exposure broken up into deciles, where the units are micrograms per cubic meter. So at the lowest level, you can see that there's a certain amount of relative risk of Parkinson's disease, and then it kind of goes up as you go through. Now, the first thing that I want to say is the error bars in this data are huge. Now, normally this does not pass the kind of like rigor or sniff test for me, but there's a couple reasons why I would take this data seriously. For one thing, there are a tremendous amount of factors that I would expect to basically, if there was, let's say there was a true correlation, I would expect that data to be very messy. There might be areas where even if overall the concentration of TCE in the groundwater is high in this region, that doesn't necessarily mean that you yourself will be exposed to a lot of it. Perhaps your lifestyle doesn't bring you into contact with it. Perhaps you live in a drier area. I don't know, where like the water table is lower relative to where your elevation is, and you're just not going to be breathing this stuff in or exposed to it in any way, even though you live in one of those kind of high exposure areas. Another really important detail is that people move, especially in the United States. There's quite a bit of mobility. So maybe you're one of these people who lived in a really high exposure area for a long time, and then after decades of exposure, you do develop Parkinson's disease. But by this time, you've moved to Montana, right? So now you're not going to even contribute to the trend. You're going to actually be part of the sort of decrease of this trend. Finally, the third thing that makes me take this data seriously is that when it comes to assessing the risk of relatively novel substances, the burden of proof should always be on the novel substance to prove that it is not harmful, rather than for people to prove that it is harmful. So overall, I do think I'm pretty well convinced that the ambient trichloroethylene exposure in the groundwater does present an increased risk of Parkinson's disease, and that this could potentially be mitigated or this could be better or worse depending on where geographically you live. For me, overall, this emphasizes kind of an ongoing trend that I've been coming to in my journey to go from kind of a, let's say, a very naive and dewy-eyed scientist, young scientist who kind of only sees the potential or the good in things or technological development, to someone who is quite a bit more conflicted about the overall effect of science. I think that trichloroethylene is a very effective chemical at doing certain jobs, and so people started working with it. And when people started working with it, they adopted a very blasé attitude. And like I said before, when it comes to chemistry, unfortunately, familiarity really does breed contempt. So anyway, I hope you find this useful. I don't necessarily have a takeaway, like, if you live in one of these high concentration areas, I'm not recommending that you move away or something. I think that, the exposure is what the exposure is going to be. Let's try not to panic about it. But in the future, we should all try to be a little bit more careful about what sort of new technologies we adopt. I think any new chemical substance that's introduced into human use should definitely undergo a lot of screening. So I hope you find this useful or entertaining in some way. And if you did, please go ahead and like and subscribe. And I hope to see you here again. Bye.